Hello, everybody. Welcome to Hurricane Center Live. We are glad to have you along again. We're recording on August the 12th of 2026. This is episode 146 of Hurricane Center Live, and we're glad to have you along. Jeff Lindner is going to join us in just a moment. Excited to have Jeff here. A lot to talk about with what's going on in Houston and Harris County. A quiet year, but that's not always been the case. So we'll talk with Jeff in just a moment. Let's thank our sponsors who make these shows a possibility week in and week out. We start with USAA. From the very beginning, USAA has been part of what we do at the National Tropical Weather Conference, at Hurricane Center Live, and everything we do. We appreciate that. The South Padre Island Convention and Visitors Bureau, the host for the National Tropical Weather Conference. We'll be back there live in 2027 at the Hilton Garden Inn. Hope you'll join us there. Live View, folks who make our broadcast back to our home markets possible. We appreciate them. And the Texas Weather Network, newest members of the club, if you will. Joining us as always this morning, former director of the National Hurricane Center, unbeknownst to the rest of us, apparently he was the only passenger launched on the SpaceX rocket into space and was deployed with all the Starlink satellites. Bill Reed, where are you this morning?
22,000 feet up, looking down at the tropics.
Good to see you, Bill. I assume you're back in Southeast Texas in your normal spot.
Yep, enjoying the 78-degree dew point as usual.
All right, very good. Glad to have you along, Bill. Dr. Hal Needham, Hurricane Hal from the Geotrek podcast, somewhere in Southeast Texas as well. Probably an even higher dew point than Bill, right, Hal?
A higher dew point, but a lower elevation. I'm at 10 and a half feet above sea level, which is where I live. So I'm pretty close to the ocean here in Galveston Island.
That lovely tropical plant growing behind you, so you're right in place. It's good to see you, Hal. How are you, buddy?
I'm doing well. Great to be back with you guys. I've been traveling a lot, but love being back here on Hurricane Center with you guys.
We'll be anxious to hear about what's going on in Geotrek a little bit later on, because I know you've been traveling. You got some cool stuff happening, so we'll get to that in a little bit. But Hal, take it away, introduce our guest, and let's get this conversation started.
Oh, yeah, this episode is going to be a fan favorite. When heavy rain threatened Southeast Texas, few people understand the flood risk better than Jeff Lindner. He's a meteorologist with the Harris County Flood Control District, helping translate weather forecasts into real-world flood impacts. Jeff, great to have you with us here on Hurricane Center.
Absolutely. Thanks for having me. Good morning, everybody.
Jeff, I love watching your extreme weather communication, your flood risk communication. It's very applied, very focused on impacts. You're often sharing some of these amazingly robust web tools developed right there at the Harris County Flood Control District. Could you share us about some of the products that you share with your audience when floods threaten Southeast Texas?
Yeah, I think the biggest one we have is what we call our flood warning system. And this is a network of gauges that is deployed not only across Harris County, but across the region. So we have Fort Bend County, portions of Galveston County, Brazoria County, Montgomery, Waller County, and all of that data comes in real time. So you get rainfall data, you get water level data in the creeks and the bayous and the rivers. And all that comes in real time, and you can view that at the website, which is harriscountyfws.org. And so you can watch the rain accumulate. You can change the times. If you want to look at 15-minute rainfall or 1 hour rainfall or 2-day rainfall, whatever you want to look at. And then you can also look at the water levels in the creeks and the bayous, which is kind of the more important thing if we're dealing with a lot of heavy rainfall. And you can see that the rises that are occurring, the recessions that occur. And you can also look at what we call inundation mapping. So this is kind of the footprint of, if we do have flooding along these creeks and bayous, kind of the footprint of where that water is. So it updates about every 15 to 20 minutes. And it gives you an idea if the water is getting close to your location. You can put your address in and see where your house is and kind of where the water is located in proximity to your house. And then lastly, you can get text messages from all of these gauges out there. So you can get a text message. We have some default ones that you can sign up for. You can build custom ones. So if you know you want to know when a certain bayou is half full, you can create a custom alert that sends to your cell phone, hey, such and such bayou is half full. FYI. So we've done a lot of work on that. We also have a forecast system we've been working on. We're actually executing a contract hopefully next month with Texas A&M to do some AI modeling with our forecast system. So at each one of these gauges, we would be forecasting water level out in time. And that there's a lot of promise, I think, with the computing power that they have at A&M to kind of push some of this machine learning. We feel like we've reached the limit of what we can do with the legacy models, with the hydro models that we have, and kind of push the limits here with the machine learning type stuff. That seems to be a big, talk in our field of how things are going to go forward with forecasting. And then the other thing we're going to do with Texas A&M is actually develop a localized rainfall model. So the biggest problem if you think about flood forecasting is you got to get the amount of rain and the location right. And we kind of struggle in that field, as good as some of our stuff is out there, the H triple R, the HREF, some of these high resolution meso models, you still might get the location right. You might not get the location right, and you might be off a couple inches or several inches even on the amounts. And so we're going to work again with that with A&M to try to develop a machine learning model that can hopefully get us some better accuracy on those. And because the whole point is when's it going to rain, how much is it going to rain, and what are the impact going to be? So if we can answer the first two questions, we can answer the last one. But getting to that point, I think we're kind of at the end of our what our models can do at the moment.
Yeah, Jeff, we see a lot of convective rainfall in Southeast Texas, a lot of very localized bullseyes. Does that explain why the Harris County Flood Control District has such a dense network of both rain gauges and stream gauges?
Yeah, that's an interesting question. We have one of the densest networks in the nation, one of the most sophisticated networks in the nation. I'd like to say yes, but the real answer is people just want to keep adding gauges. There's been a lot of money that's kind of flooded the market ever since Harvey. The state's been handing out a lot of money. What happened out in the Hill Country last July and then a couple weeks ago really pushes the flood warning aspect and the need for data and alerts and warnings. What's interesting, and we're kind of starting to look at this a little bit, is going forward in the future is actually putting physical gauges out in the field going to be what we're doing in 10 years. It's a lot of equipment, it's a lot of maintenance, it's a lot of money, it's a lot of funding, it's a lot of time. With technology advancing as quickly as it is, especially in the machine learning and AI world, I suspect in 10 years we'll be probably doing something different. There's a lot of effort right now with cameras to be able to do a lot of things and not put so much equipment. A gauge can cost $10,000-$15,000. And so, you have to have a person to go out there and work on it. You have to maintain it. What can we do in the future to kind of limit some of that stuff? And I think AI and the camera technology may be where we end up. I don't know for sure. But we're going to start testing some camera stuff also coming up. So yeah, a lot of the explosion of gauge networks, not only in Harris County, but in Texas, has been the results of the big floods we've had.
Yeah, Jeff, the concept of camera surveillance, could you see that more focused on surveying the water level in a creek or bayou? Or could you also see a lot of that focused on, say, roadways where maybe a creek crosses a road, or maybe some kind of a hybrid of both of those?
I think we're going to end up with both of them to some degree. And I also think with the technology on vehicles nowadays, you have sensors on your tires that tell you if the air pressure is getting low. Those same sensors can also tell you if the tire has water over it. And so we've actually done some work with Waze and Google, and there's some effort there to be able to look at street flooding. And so if the water's a certain level over the tire, the issue we have is a lot of this type of technology tells you, yes, there's water, but it doesn't necessarily tell you if the road's passable or if the water goes down. Obviously, if people aren't driving down the road, you don't know if there's water over the road in that type of a situation with the tire sensor. And so there's some, I think, again, there's some really smart people out there that can probably figure this out tomorrow. But I think the future is going to be a combination of sensors that are being put out anyways, that we're not necessarily going to go put out and pay for, that they're already going to be out there, And then probably some camera technology, along with leveraging radar. Radar can really answer a lot of these questions with the rainfall rates and stuff like that, which has been a product we've had. It's just how do you get that into a consumable format for the general public to use and make decisions on?
Wow.
Yeah, Jeff, last question, and then I'll pass it over to Bill. So with the advances in radar, essentially, could you see that really supplementing or, complementing the network of rain gauges where maybe radar could do a pretty good job of showing us the spatial coverage?
Yeah, and we already do that now. So obviously, even though we have a really dense network, we still use radar to fill in the gaps between our gauges and to get the full picture of what's happening in the entire watershed, not just exactly where the gauge is. If you think of a gauge, it's a point. But some of these watersheds are several thousand square miles. And so what falls between those gauges is just as important as what falls at it. And as you mentioned, how we're so convectively driven here, you can get 4 or 5 inches of rain and at the gauge get nothing, and very short distance away get significant rain. And so leveraging radar, we already do. We do a lot of what we call the MRMS and the QPE data. So we're the products that we come in. We pull that in and look at that, and we also do some of that with the HER. So the HER can do some short term forecast stuff that we pull in and look at very closely. So we're utilizing a lot of that. What's interesting is if you start utilizing some of that with AI and building some ensemble stuff, that's when it really gets interesting. But you got to have the computing power more than we can do on our desktops, and so that's hopefully what we're going to leverage with AM.
Thanks, Jeff. Bill, I know you're dying to ask some questions. Let me pass the mic over to you.
Yeah, I'm dying to go back wind the clock back about 30 years and be a player in all this. It's very exciting stuff. I would think they're probably already talking about this at A&M, that taking the MRMS concept and resolving it down to the scale of your area of responsibility, and to get the diagnostics correct, and then the AI concept for the forecast would be that sounds like a tremendous way to maybe get some lead time on the challenges for some of these narrow drainage areas you have for your basins, to get a good forecast for the flood.
Yeah, I think we're working with a couple of professors up there, and there's different lines of thought of how to go forward with this. I think the base is going to be the HER, or the new HER that's coming out. The HER is being discontinued, I think, right, coming up in the fall. And so the base is going to be that, and then running that through some type of ensemble approach with AI. Texas Tech is also working on a statewide model funded by TDEM to produce a new statewide convective allowing model. So that should be interesting too. And we would hope that we could coordinate with both of them and work together to see if we can leverage some of that. Because we know as soon as we do it for Houston, everyone's going to want it statewide, and so or nationwide. And so we'll see how this goes forward with everything. I think there's not a lot of real confidence on what this is going to turn out to being. We've just kind of seen what's happened with the AI revolution with the Google and all that, with the tropical cyclones, and think that we can leverage on some of that with the rainfall side.
Yeah, it's as long as people, boy, am I assuming something. People that make decisions understand that we're still in the learning phase on how to use this, to let these things try out, see what works. If it fails, what do you do? Go back, correct it, and try it again. It's got to work. And I can testify to the challenges of the variability. I've got 3 of your gauges, 4 now. 4 are within the 1 to 2 mile radius of my house. And the kind of storms we've had lately, I had like 1.6 inches the other day, and the highest in any of the other 4 gauges was 0.4. Yeah. I thank you for that. My yard needed it.
Yeah.
Kind of shifting gears here, one of the issues that sticks in my craw, I'm sure, and you guys too, is we can't seem to get past the issue of building too deep into the flood-prone areas, and it's become headlines recently. It sounds like the lessons learned from Harvey are slowly being forgotten, and people want to develop down into the lower floodplain. I'm not even all that confident that the floodplain information that's currently official from the FEMA maps there is very good. Any thoughts on that?
Yeah, we could probably spend an entire time talking about one or the other on that one. The biggest problem that Houston historically has faced is we've built an area that we probably shouldn't build, or if we built there today, we'd build up. And so we have a lot of areas that were built back in the 50s, 60s, and 70s. The first floodplain maps for this county came out in the early 80s. So folks really didn't know how deep they were building in the floodplains. We didn't really have any maps that said anything like that. If you really kind of think about it, Houston sort of gets a little bit of a bad rap for its flooding. It's really no different from New Orleans or any place along the Gulf Coast. There's folks in New Orleans that flood, and they have a different situation there, but the structures still flood there. But for some reason, Houston's like, it's always flooding here, and you see the images of the streets that flood. The streets are designed to flood. We don't have as much house flooding here as we had even when I started. When I started back in 2003, 2004, 4 or 5 inches of rain would result in structure flooding. Now 5, 6, 7 inches of rain, we don't have a lot of structure flooding. And so we've actually made a lot of progress. But the problem is progress is hard to measure when you also put storms in there like the tax day flood, or you put Harvey in there, and that's all people remember is the whole area flooded and all these hundreds of thousands of homes flooded. And if you look at the progress we've made with flood mitigation and flood risk reduction, we've made a lot of progress. I mean, we really have. But if you look at the progress we still need to make, it's going to end up costing about $60 billion. That's with the B. And so the bond that was passed after Harvey to help reduce flooding risk here was $2.5 billion. And so you can see there's a little bit of a gap there to bring that 100-year flood protection to Harris County. When you talk about floodplains, that's a whole nother can of worms. What I tell everybody here, everyone's in a floodplain. Some of us have a greater risk. Some of us have a lower risk, but we all have a flood risk here. Honestly, if you live here long enough, you're probably going to flood. And when the day comes, when you get your Claudette or you get your Allison or you get your Harvey over your neighborhood, the chances are that drainage system's just not going to be able to handle it. And so we always harp on that. There's so much emphasis, especially now, so much emphasis put on these floodplains, and they kind of only tell half the story. They only tell the flooding from the creeks and the bayous. They don't talk about the flooding, or they don't indicate the flooding from the roadway systems that, it just rains 5 inches an hour in your neighborhood, and the underground system can't handle it. And so you get 2 or 3 inches of water in your house for an hour, and then it goes down. But that's damaging, and you're not in a floodplain and all that type of stuff. And so I just always stress that this whole place is a floodplain. The Gulf Coast is a floodplain, and we're going to get these big rains that we're going to have flooding inside and outside of our determined floodplains.
That's great. That's kind of what I used to do all the time was saying we're flat here, and the kind of rains we get, you can't discharge it into the stream system fast enough, and if you just forget about the floodplain and realize that you're at some kind of risk, and how much are you willing to shoulder without buying flood insurance?
Yeah, that's exactly right. And there's been a lot of differences and changes with FEMA and the flood insurance program and the maps and the mapping and all that kind of stuff. And so how we deal with all that going forward is constantly changing also.
Good. Let's take our mid-show break, guys. This is fascinating. Great conversation. Jeff would just really enjoy hearing what is happening and what has happened. But let's take our mid-show break. Let's thank our sponsors who are part of the program week in and week out. We thank USAA. I want to thank the South Padre Island Convention and Visitors Bureau, Live View, and the Texas Weather Network. We have a tropical update for today. Bill, before we get to that, I want to show you all something that crossed my Facebook feed this morning. That's the WTF moment of the day. And I know that's pretty small on your screen. And if you're watching on your phone or you're listening, I'm just going to tell you a little bit. I'm not going to tell you where it came from, and I know it's on there, but that's, I don't want to share them. But it says the National Hurricane Center is tracking a disturbance in the eastern Gulf with development odds now at 80%, with formation of a tropical depression possible within the next day. Regardless of designation, meteorologists say repeated rounds of heavy rain, blah, 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 blah. It says Weather Source, National Hurricane Center, forecast issued August 10th, 2026. And then there's an image there of a big bad storm or something forming in the Gulf with an 80% circle over it. It does have the date of September 11th on the graphic itself. Bill? I hate to hand it over to you because I don't think Alex has a bleep button, but it's just the misinformation is irresponsibility of it. That's not what's out there at all.
Yeah, if I could invent a system where if I saw that and knew where it came from, I could send a large electromagnetic pulse in there and fry their computer, I would probably do it.
We've got a guy named Guido we can send over there that can take care of it. Yeah, but go ahead and give us a real tropical update, Bill. What's going on? It's just disturbing what people are doing for clickbait nowadays. So let's give them the real thing.
Okay, let me share the screen here and find where I was at. That one. As I always say, now that we record this for later viewing, that this is Wednesday morning, August the 12th. Please check your reliable sources for what's going on when you see this and want to see what's up the latest in the tropics. It's changing as we speak. Before we went into this recording, the updates were starting to come in from the National Hurricane Center. I guess this is now going to be Cristobal up here in the subtropics, heading kind of towards the Azores, but not really considered to be much of an issue. These are two systems, two waves that came off of Africa. We're coming into the African easterly wave season, and in spite of El Nino, those things keep coming. The impacts from the El Nino, strongest felt will be when it gets into the western part of the tropical Atlantic, and the dearth of clouds in here is somewhat indicative of that. We've had that all season. A lot of dust and dry air, and a lot of wind shear once it gets over here. So those are the systems that the Hurricane Center is monitoring, as should we. I'll update this screen for you. There's Cristobal. And again, it's not going to be an issue for any of us. These two kind of bear some watching, especially if for people that have shipping interests. For one or both of these may escape the hostile environment that they're heading towards in the Caribbean and get into the subtropical region where they have some minor chance of developing. But those are the ones you need to monitor going forward. Just an example of the DeepMind's idea on these. It doesn't think much of the lead one that the Hurricane Center has the 80% on, but it does pick up on the second one coming out and take it out into the open Atlantic, where it could have it. But remember, this is a 1,000-member model, and those are only a handful of streams. So again, the odds are really not that high. Of more interest, actually, is what's going on out here in the Central Pacific. What looks like an almost amorphous blob of clouds is a huge area of convection. Normally, you don't see much out there, but again, with the big warming from El Nino in there, the chance for moist atmosphere and instability and thunderstorms is much higher in an El Nino year, especially one like this. And it's been on a high probability watch. And again, before we started this recording, the Hurricane Center upped the ante on this. Let's see if I could get this into the right mode. There we go. In this case, it's still a 90% chance of development, but they should have some trek information. And again, let's get that up here real quick. There we go. Come on. The first forecast out on a potential tropical cyclone, as you can see, definitely impacts the Hawaiian Islands starting this weekend. Mainly over the weekend in there. And pretty much all hazards are at play other than storm surge. You'll have high waves. You'll have some heavy rain. And And it's been dry out there. There's some concern that as the winds pick up before the rains, it could even produce a fire hazard in advance of the storm itself. So anybody with plans to go to Hawaii on there need to pay attention to what's going on in there. And for the Josh Morgermans paying attention to this is the outlook that the Climate Prediction Center puts out, showing what might happen in the weeks 2 and 3 beyond the official forecast. The brown is drier than normal. You have to have the various red colors to get a risk of tropical cyclones. So it pretty much continues what we've been seeing. Westpac and far western portions of the eastern Pacific into the central Pacific being the prime areas to look at. Unless you guys have comments on the tropics, here we are.
Great job, Bill. Thank you. We appreciate that. Always at least something going on. Fortunately, the Atlantic still is where we like to see it. Not a whole lot happening. How, what's going on with GeoTrek?
I just did some field work in Colorado investigating their deadliest flood from 50 years ago. I was in Big Thompson River Canyon, and I came across this very interesting sign from USGS. It compared the rainfall from the big flood of 1976 that killed 144 people, compared that storm to a storm that hit in 2013. What shocked me is the 2013 storm actually put heavy rain across a much larger area, but the river flows were much lower. How can a bigger storm produce lower river flows? The key was the duration of the event. The 2013 event produced heavy rain over 3 to 4 days, but in 1976, they got about 10 to 12 inches of rain in about 3 to 4 hours. It taught me as a forecaster not only to look at how much rain is going to fall, but the duration of the rain, especially if you're looking at riverine flooding. It was a good lesson for me, and I wanted to pass that along to our listeners.
Terrific. That's I can't wait to hear your podcast and everything you're doing on this. We appreciate that, and convert that into our next question for Jeff. That how important is that? Not just amount of rain, but duration of the rain, how quickly it falls.
Yeah, it's probably the most important thing we face, not only in the Houston area along the Gulf Coast, but even back out in the hill country and out in the mountainous areas. It's that duration, and we kind of key in as meteorologists. We key in that hourly rainfall rate, so that shorter duration rate. And for us here in Harris County, when we start getting an inch or so in 15 minutes, that's when we really start to get concerned about some really deep street flooding. Not so much the bayous. For the most part, they can handle that type of rainfall. It's if it keeps going for 2 or 3 hours and you start adding up to 8, 9, 10 inches of rain, that's when we really start to get concerned about the bayous. But from a street flooding standpoint, you start getting those inch in 15 minutes, and it's more common, I think, than people think. Down here on the Gulf Coast, it happens almost daily when we get those convective storms go up, and you can get 3-4 inches of rain in 30 minutes, an hour, and then moves on, and the street flooding happens and it goes down. So rainfall rates are incredibly important in forecasting flooding.
It's been 9 years since Harvey. We're coming up on the 9th anniversary, which is crazy. That was 9 years ago already. But no two storms are alike. It doesn't have to be a hurricane. It can be anything almost anything can create that kind of rain in the Houston area. But if we had another Harvey-esque storm, would the result, do you think, be the same, or would it be different now? Has everything changed enough that we would see any kind of a different outcome today than what we saw 9 years ago?
I really don't think the outcome will be a whole lot different, and I think that's going to be a hard pill for a lot of people to swallow. But when you're talking about the amount of water that Harvey dropped, it doesn't matter what infrastructure improvements you've made and the projects you put into place. That amount of water so greatly exceeds the designs of most of our flood capabilities that the flooding would still be disastrous. We might say we could maybe 500 homes might not flood, or the water might not be 2 feet deep. It's only 1.5 feet, but it doesn't matter. Water in your house is water in your house. And I think that's where people really need to kind of understand that. Even if we had other storms, forget Harvey for a minute. Harvey's kind of off the scale. But if you look at the Tax Day storm or the Memorial Day storm that we've had here, or even what happened out in the hill country, the flood that just happened out there recently with the 10, 20 inches of rain, we would still have very significant flooding. We would still have thousands of homes flood because we just don't design. We can't design for that amount of water in that time period. And so you have to kind of think of it as you're taking so much water in a short period of time and trying to squeeze it down through a straw, if you will, or a water hose and try to get it out of here. That's kind of what we're up against here. And so, yeah, unfortunately, I think the answer is not what most people want to hear, because I think we can solve this and we can work at making it better, but we will never solve the flooding problem. I mean, it's just like New Orleans. They've done a lot of work there with strengthening the levees, maintaining the levees, but there's always going to be that hurricane that can exceed that design and flood the city again. And so this is the same thing here. And unfortunately, it's the same thing out in the hill country. You know, all this effort has been put out in the hill country with warning systems and all that type of stuff. But that will happen again out in the hill country. It won't be probably on the Guadalupe, but it'll be somewhere else, where we see, you know, the big floods out there and the RV camps and the camps down along the river and all that type of stuff.
It will happen again. That's the message there. We're coming up on the end of the program. We got time for one more question from each guy. So, Bill, final question. I've got a whole page of them, but one question, Bill.
Yeah. What big engineering thing do you think is being planned that might help with the flood situations here? I know I've heard of a lot of ideas, but do you have one that in particular that might have some fruit to bear?
If tunnels stick, tunnels will probably be the generational seawall of Galveston type event for Harris County, the city of Houston. It would be a massive infrastructure project, you know, of the likes of the New Orleans levees or the Galveston seawall. But it's extraordinarily expensive. We would obviously need federal help, federal funding to help do this. But it would, from what we've seen, the tunnels would significantly reduce the amount of flooding that we experience along our creeks and bayous.
Hal, final question.
Yeah, Jeff, how well do the models forecast the training of like convective cells going over the same area again and again? Do we handle that pretty well in the models, or is that more of a challenge?
It continues to be a challenge. I think there's not a lot of difference between, say, training convection and just the pulse type pop-up, slow moving, merging thunderstorms that produce a lot of heavy rainfall. It's just the where. If you have a decently defined boundary, you know, it can kind of give you some clues within a 3 to 4 hour period. Hey, we think it's going to be along that. Or if we're in the cool season, we actually have a front kind of in the area that helps a lot. But in the warm sector season, you know, these little outflow boundaries can move around and clash with each other and stall out or keep moving. And it's just very difficult to say when and where and why.
Thank you.
Jeff, great stuff. What are your final thoughts today? What do you want to leave us with and our audience on this mid part of the hurricane season 2026?
Yeah, you know, it's been a focus this year. It's been a challenge this year. I don't know how much y'all talked about this, but it's been a challenge this year to kind of keep people engaged in preparation for hurricane season when the numbers have been kind of on the low side. And we've all known this with the El Nino coming, that this was going to be a lower end season. With respect to the numbers, we'll see what kind of impacts we end up with. But you know, we've started to we put such an emphasis on hurricane season in our field, and the kind of movement I'm seeing more and more is a 365 preparedness. It's not always the big hurricanes and all that. We can have floods, we can have winter storms. We've had more winter storms in this state that have caused problems recently than the tropics have caused us. The last two big events in the state have been the hill country floods and the devastation and the loss of life that we saw out there. And the one that kind of never really gets talked about is wildfire. I mean, we've had wildfire in this state and up in the Panhandle that has been devastating. And so it is this kind of culture shift to move towards a year-round preparedness. You know, the same thing you do for a hurricane, loss of power, all that type of stuff you can use for a lot of these other disasters. And being prepared and knowing your surroundings, knowing where you can get information, knowing where you can get proper, correct information. As you mentioned, there's a lot of stuff out there that's absolute trash. And when you have a disaster, it's even more trash out there. And so being able to get that and know where you can get that information and know what to do when you're maybe not at home, you know, you're on vacation in the hill country or in Colorado when something happens. I think that's kind of where we're seeing more of the preparation field move instead of, June 1st, go buy your water and batteries.
Great information. That's absolutely true. Here in South Texas, we have used to be the South Texas Hurricane Conference. Now it's the All Hazards Conference, just to follow what you're saying. And that is so important. Jeff, thank you. We really appreciate your time today. Great information. Keep up the great work you're doing in Houston and Harris County. You're making a difference there. And thank you for that.
Thank y'all. Thanks for having me.
We appreciate it, guys. Great program today. Next week, Scott Withers, meteorologist and author. Let's see, he wrote Hurricane Ian, the book and the experience, a survival story of how he got through Hurricane Ian and survived the storm surge. That should be a good program next week. So that's next week. Until then, for Hurricane Hal, for Bill Reed, for Alex Garcia, I'm Tim Smith. Thanks, Jeff Lindner. We'll see you next time. Bye-bye.